Okay, now, we know that if acceleration is constant a, then the velocity is at plus c1, x of t is 1/2 at squared plus c1t plus a c2. The c1 being the integration constant from when you go from acceleration to velocity, the c2 being the integration constant when you integrate the velocity. Now, if v naught equals if v of 0 equals v naught, or I should have really said v naught is equal to v of 0, because that's how we want to define v naught, and x naught is equal to x of 0, then what are the values of c1 and c2? And this is rather immediate. I think everybody understands this quite well. If v of 0 equals v naught, well, v of 0 also equals a times 0 plus c1, and from that we immediately see that c1 is equal to v0 because a naught is 0. And similarly, x naught equals x0, and that equals 1/2 a times 0 squared plus c1 times 0 plus c2, and that is just c2. So c2 has to equal x sub 0. And we then conclude that v of t is at plus v naught, and x of t is 1/2 at squared plus v naught t plus x naught. Okay. Now we're going to use these, and something arose in analyzing this that I hadn't anticipated, because I did this early in the morning when I was a little bit groggy and hadn't really done it this way before. It just occurred to me that from where we are, this would be a good place to go. So everything is okay, but there is a place in our analysis that's going to, the subsequent analysis, where we're going to have to say a miracle occurs. And I want to fill in that miracle, okay? So I'll tell you where we fill in the miracle, or what we fill it in with, and then I'll go ahead and do it. And when we get to the place where we have the miracle, I'll indicate how that's resolved. And it's resolved with a simple picture here and a very, very simple statement here. But we'll talk about that after we define these things. V sub I, then V sub I is going to be V of t sub I, where t sub I is regarded as the initial time in some time intervals, like we're observing something moving with uniform acceleration, and we observe it at one time and we observe it at another time. What are we going to see? What's going to happen in that time interval? What's the average velocity going to be? What's the displacement going to be, and so forth? And how is everything related? And that's going to lead us to just your general V versus T trapezoid, and to what that trapezoid tells us about motion on an interval. Okay, so V sub I is going to be V of T sub I. T sub I being the time at the beginning of this interval, and X sub I is X of T sub I. That's the position. Now, did I say V of T sub I is the position? V of T sub I is the velocity at the initial instant, and X sub I is, of course, the position. And we get that. V sub I is V of T sub I, and that's equal to this. I won't read it to you. And X sub I is X of T sub I, so we plug T sub I into the X of T function, and we get this. And then V sub F is this, and V sub I is this. And I wrote down V sub I twice because I was really supposed to write X sub I here, but it works out that I wrote V sub I here because the delta V is going to be easier to see if we've got both VF and VI sitting here. And you know what you would have written for X. I said you should have written X sub I. That would have been the second time. We're really supposed to write X sub F here. So I never did write that out, but you know what it is. So you'll see what to do. Okay, so delta V is VF minus V sub I. Now I'll use this V sub F and this V sub I to see clearly what this is, but if you just write out what V sub F is, V of T sub F minus V of T sub I, plug in the T sub F and the T sub I and go to all the trouble, you're going to end up with this, A times T sub F minus T sub I. And why is it? Well, here's what you get if you plug in for V sub F. Here's what you plug in T sub I into the function for V of T. And if you subtract this from this, you'll be subtracting V naught from V naught. And if you subtract this from this, you're going to get ATF minus ATI. Factor out the A, you get A times TF minus TI. And that's just A times delta T, the way I define delta T. And I didn't write that definition down on the board, but delta T is just TF minus T sub I. Okay? And then our delta X, if we do the same thing, if we write out the expressions and subtract them and simplify things, we get this. Okay? First, A times TF minus TI. Oh. I hope I didn't do that down here. Times TF squared minus TI squared. Okay? Which means it's not what I say it is there. So I'm going to stop the video right here and figure out how that's going to reconcile with everything else.